Assalamualaikum. So my name is Aina, and today I would like to explain about atoms, molecules, ion and chemical equation. So atom is the smallest particle of an element that retain the characteristic properties of that element. So it was made up of 3 subatomic particles that contains protons, electrons and neutrons. So electrons can move around the nucleus in circular orbits called the energy levels, and nucleus is the center of an atom. So atomic number is number of protons in the nucleus of an atom of any particular elements. Number of protons means number of electrons, and mass number is total number of protons plus neutrons in the atom. So like the example, X is atomic symbol of the element, A mass number, proton plus neutron, and Z is atomic number, the number of protons or electrons. So as you guys can see, this is the periodic table of elements. And then this is some common or basic elements and their symbols, like aluminium, fluorine, oxygen, hydrogen, phosphorus, calcium, carbon, chlorine. And then we have isotopes. So isotope is atom with identical atomic numbers but different mass number. Most elements have 2 or more isotopes. Isotopes have different numbers of neutrons. And then molecule. Molecule consists 2 or more atoms that are chemically bound. It was combined in specific ratio to one another. The next one is compounds. So compounds is a substance composed of atoms of 2 or more elements chemically united in fixed proportions. Compounds can only be separated into their pure components, elements, by chemical means. And then we have ions. Ion is an atom or group of atoms that has a net positive or negative charge. In any given atom, the number of protons is always equal to the number of electrons. Neutral atom can lose or gain electrons and become charged. The charged atoms are known as ions. So we have types of ions. We have cation and anion. So cation is ion with a positive charge. If a neutral atom loses 1 or more electrons, it becomes an cation. And the anion is ion with a negative charge. If a neutral atom gains 1 or more electrons, it becomes an anion. And then we have types of ions. The first one is monoatomic ions. A monoatomic ion contains only one atom, such as H+, Li+, Mg2+, Ai3+, and N3 negative. The second one is polyatomic ions. A polyatomic ions contains more than one atom, such as Cn negative, MnO4 negative, and SO4 2 negative. So this was the common ions shown on the periodic table. And then we have naming ions. Naming metal ions is maintain the name of the metal. We need to add ion at the end. In A+, it was sodium ion. Mg2+, it was magnesium ion. Naming monoatomic anion is non-metal. We need to add IDE to element name. Cl was Cl negative, and chlorine, it was chloride. Here we also have cations and anions with their charge formula and name. So here we have naming ionic compounds. It was often a metal plus non-metal. So the example like compound BaCl2, the ions present is Ba2 plus and Cl negative. The name of the compound is barium chloride. And then the second one is K2O. The ions present is K plus and O2 negative. The name of the compound is potassium oxide. And then the last one we have polyatomic ions. So to naming the polyatomic ions, we can refer the list.
The definition of hydride ionic compound. Hydride ionic compound have a specific numbers of water molecule attached to them. The water molecules is shown after a dot and named by the Greek numerical. Use it before the words of hydrate. This is the Greek numerical, and the example of hydride ionic compound, which is calcium sulfate dihydrate and calcium chloride dihydrate. The definition of naming molecule compounds, which is non-metal or non-metal plus 3 metalloids, and the element that farthest to the left in a period and closest to the bottom of the group is placed first. The last element ends with IDE. This is the periodic table that we can use, and this is the example of molecule compound, which is mono, NO, nitrogen monoxide, and Di, NO2, nitrogen dioxide. The definition of atomic mass. The mass of an atom element compared to that one atom of 12 carbon. The example of atomic mass. 1 hydrogen equal to 1.008 AMU. Relative atomic mass. The weighted average of all naturally occurring isotopes of the elements. This is the example question that we can solve, which is the isotope from each element will multiply with the relative abundance percent and divide with 100. The final answer we get, which is 24.32.
Assalamualaikum and hi everyone. My name is Idina Batrisha binti Saupi and I will explain about formula empiric and molecular formula. Formula empiric is the simplest whole number ratio of atom in a compound. So, there is an example question for formula empiric. Mercury form a compound with chlorine that is 73.9% mercury and 26.1% chlorine by mass. What is the empirical formula? So there's 4 steps to calculate the formula empiric. First, you need to identify the mass for each element. Second, we need to convert the mass of the elements to moles. Third, we need to divide each mole's value with the smallest number of moles calculated. And 5, we need to round the nearest whole number. Next, molecular formula. Molecular formula is show how many atoms or ions of each element combine to make that compound. So there's an example question for molecular formula. For a compound whose empirical formula is CH2, the molar mass of the compound is 56 gram per mole. Determine the molecular formula of the compound. There is 3 steps to find the molecular formula. First, we need to calculate the mass of the empirical formula. Second, we need to divide the molar mass of the compound by the mass of empirical formula to find the ratio. Third, we need to multiply all the atoms by this ratio to find the molecular formula. So let's calculate together. CH2 molar mass is C has 12. We need to plus with H 1 multiply 2 and we got 14 gram per mole. And we need to divide 56 gram per mole with 14 gram per mole and we got 4. So we need to multiply the empirical formula with 4 and we got C4H8. So that's all.
Alright, so last we learned about stoichiometry calculation. Alright, next, what is stoichiometry calculation? So, stoichiometry calculation is the calculation of reactant and product in chemical reaction. In chemical equation, the formula reactant are written on the left side on the equation, while formula of product is on the right. Stoichiometry calculation, we will learn interconverting masses, moles, and number of particles. Alright, next, this is the step how to doing stoichiometry calculation. So first of all, you need to write balanced equation. and convert the quantities of non-substance into moles, and use coefficient imbalance equation to calculate the number of mole of sub quantity and convert moles of sub quantity into desired unit. Okay, so let's try to do this exercise. The question is, copper is obtained from copper sulfide by roasting it in the presence of oxygen gas to form powdered copper oxide and gas sulfur dioxide. A. How many moles of oxygen are required to roast 10 mole of copper sulfide? B. How many grams of sulfur dioxide are formed when 10 mole of copper sulfide is roasted? C. How many kilograms of oxygen are required to form 2.86 kg of copper oxide? Okay, so let's go through for the first question. So first of all, for this question, you need to write balance equation, which is 2Cu2S plus 3O2 from 2Cu2O plus 2SO2. And then you can calculate the ratio, which is 3 mole O2 divided by 2 mole Cu2S equal to X mole O2 divided with 10 mole Cu2S. Then you need to solve the X, which is 3 multiplied with 10 divided by 2. Then you will get 15 moles of oxygen that required to roast 10 mole of copper sulfide. Okay, for the second question, how many grams of sulfur dioxide are formed when 10 mole of copper sulfide is roasted? So you need to calculate the molar mass and mass of SO2, which is the molar mass of SO2 is 2.7 gram per mole sulfur plus 2 multiplied with 16 gram per mole oxygen, and then you will get 16.7 gram per mole. And then the mass of SO2 is 10 mole multiply with 64.7 gram per mole, then you will get 614.7 gram. So 614.7 gram of sulfur dioxide are formed when 10 mole of copper sulfide is roasted. For this question, you need to write balance equation first, which is 2Cu2S plus 3O2 from 2Cu2O plus 2SO2. The molar mass of Cu2O is 2 multiplied with 63.55 gram per mole plus 16 gram per mole, and then you will get 114.10 gram per mole. So the moles of Cu2O is 2.86 kilogram divided by 143.10 gram per mole. Then you will get answer 20 mole. From balance equation, 3 moles of oxygen gas are required to form 2 moles of copper oxide. Therefore, the number of moles of oxygen required to form 20 moles of copper oxide is 3 mole of O2 divided by 2 mole Cu2O multiplied with 20 mole Cu2O. Then you will get 13 mole of O2. Then you need to convert moles of oxygen to gram, which is you need to calculate the mass and the molar mass of O2. So the molar mass of O2 is 13.2 gram per mole, and then the mass of O2 is 13 mole multiplied with 13.2 gram per mole, and then you will get 916 gram. So you need to convert 916 gram to kilogram, and then your final answer you will get is 0.960 kilogram of oxygen that are required.
Okay, I am Hanismia Sarah. So now let's move to limiting reactant and excess reactant. Do you guys know what limiting reactant is? Limiting reactant is the reactant in a chemical reaction that limits the amount of product that can be formed entirely consumed during a chemical reaction. And what about excess reagent? Excess reagent is the reactant in a chemical reaction that remains when a reaction stops and the limiting reactant is completely consumed. The excess reactant remains because there is nothing with which it can react. So here an example. A 2.00 gram sample of ammonia is mixed with 4.00 gram of oxygen. This question asks to determine the limiting reactant, to find the mass of NO produced and find the mass of excess reactant remains after the reaction has stopped. So, here is steps to determine limiting reactant. First, you have to find the mole for the reactants by dividing the mass over molar mass. The mass has been given in the equation, which is 2.00 gram for ammonia and 4.00 gram for oxygen. Second, we have to divide the mole with the coefficient. The coefficient for ammonia is 4, while the coefficient for oxygen is 5. And lastly, you can determine the limiting reactant, which is the least number of mole after divide with coefficient is the limiting reactant. Now, let's go to the next question. The question asks to find the mass of nitric oxide produced. First, we have to determine ratio from the equation. Second, we have to find the molar mass of nitric acid produced. Third, we have to calculate the mass of nitric acid produced by using the mole of oxygen available and the molar mass of nitric acid. For the last question, the question asks to find the mass of excess reactant remains after the reaction has stopped. First, we have to determine ratio from the equation. Second, we have to find the mole of excess reagent, which is the mole of ammonia that reacted, by using the mole of oxygen available and the mole of ammonia available. Third, we can calculate the mole of excess reagent remaining by subtracting the mole of ammonia available with mole of ammonia reacted. And the last step, we can find the mass of excess reagent remain by multiply the mole of excess reagent remain with molar mass of the excess reagent. So that's all from me.
And then for next, we have reaction yield. We have two types of reaction yield, which is the theoretical yield and then the actual yield. For the theoretical yield is the amount of product that will result if all the limiting reagent reacted. But for the actual yield, we have the amount of product that actually obtained from a reaction. And then for the formula is the actual yield divided by theoretical yield and then times 100%. Next, let's move on to an example on how to find the percent yield. For this question, we have the reaction of 11.9 gram of CHCl2 with excess chlorine produce 13.3 gram of CaCl4, which is the carbon tetrachloride. And then they ask us to find the percent yield. Alright, so first, we need to find the theoretical yield. We need to find the molar mass of CHCl3, which is 119.5 gram per mole. After that, we need to find the mole of CHCl3, which is the mass divided by the molar mass. After that, the mole of CHCl3 times by 2 over 2 to find the mole of CCl4, carbon tetrachloride. After that, we need to find the molar mass of CCl4 and then the mole of CCl4 times by the molar mass, we got the mass of CCl4. And after that, we use the reaction yield formula, which is actual yield divided by theoretical yield and then times 100%, and we got the answer, which is the 86.81%, which is the percent yield.
That's all from us. Thank you.
Bye madam, bagi 25.